this video we will first look at type 1, where we have a to the plus x and a is larger than 1. And we're going to look at these graphs. If you want to, you can first see if you can find the equations of the green graph, the blue graph, the red graph, the brown graph and the grey graph, and then afterwards you can look at the video and see whether you're correct, or you can just go to the answers and check it there. I'm not going to discuss each of these individual graphs. Again, in this case I've used 3 to the x as my mother graph. This is the green graph here, with my domain R and my range 0 to infinity. My x-intercept, I do not have an x-intercept, but I have a y-intercept of 1. And I have a horizontal asymptote of y equal to 0. My blue graph, if I first look at the first part there, minus 3 to the x, then the 3 to the x is reflected about the x-axis, and then it's moved 1 unit up because it's a plus 1 there. The q value is plus 1. 1 unit up. My domain is again all real numbers, but what will happen to my range now? First of all, if I look at this minus 3 to the x, then the reflection will cause this domain to be from minus infinity to 0. But now it's shifted 1 unit up, so it means I can go from minus infinity to plus 1, but not plus 1 is not included. Let us look now at the x-intercept. What happens with the x-intercept? This is where y is equal to 0, so then I have 0 equal to minus 3 to the x plus 1. So that will happen when 3 to the x is equal to 1, but 1 is equal to 3 to the 0, so that will happen when x is equal to 0. So that's my x-intercept. Because of the shift, I now have an x-intercept. My y-intercept is where x is 0, so that is minus 3 to the 0 plus 1. So that is minus 1 plus 1, and that is 0. I still do not have a vertical asymptote, but now my horizontal asymptote is determined by this q value here. Just as before with the hyperbola, etc., the q value determines the horizontal asymptote. So that will be y equal to 1, which is not the x-axis anymore. If I look at my graph, this is the graph y equal to 2 to the x, and this is y equal to, it's minus 2 to the x. I've changed my y value from a plus to a minus, so now it's below the x-axis. And then I've added from b to there, I've added 1 unit, and from minus 1 to 0 I've added 1 unit. Everywhere where I measure I can see I've added 1 value. Again, I've worked out the values at 1, at 0 and at -1 and compared it. So this is my blue graph, and you can see my horizontal asymptote will be there. So my horizontal asymptote is there. Again, it looks as if it cuts that line y equal to 1, but it will never cut it. This value 3 to the minus x can never be 0, and then I just add 1 to that. Let us look what happens to this red graph. This is h of x, 3 times 2 to the x minus 2. Let us look at the first part there. So what happens with this 2 to the x? The graph of y equal to 2 to the x is stretched vertically by a factor of 3, because b is equal to 3. That b value there is 3. And then shifted 2 units down, because my q value here is less than 0, so I'm shifting down. My domain is again all real numbers. My range, what will happen to my range? If I just look at that part there, then it stays 0 to infinity, but now I'm moving it 2 units down, so it was from 0 to infinity, but now I'm shifting it 2 units down, so it's starting at -2 to infinity. So let us see whether we have an x-intercept. If I now put 3 times 2 to the x minus 2 equal to 0, then I will get 3 times 2 to the x is equal to 2, or 2 to the x is equal to 2 over 3, and that you must solve using logs. And if you do that, use your calculator, then you'll see that x is approximately minus 0.58, because you can't write this as, on that side you can't write it as 2 to the something that you know, but you can use logs to do that. Okay, so for the y-intercept, my x is 0, so I have the formula 3 times 2 to the 0 minus 2, so that gives me 3 minus 2, which is equal to 1. My horizontal asymptote will be this q value of mine. That will be y equal to minus 2, which is my q value. If I check it here, then I see first of all my green graph, because I have here y equal to 2 to the x. And this one is now 3 times 2 to the x, so it means that I've stretched the green graph vertically with a factor of 3. So 1 times 3 gives me 3, so I've stretched it vertically. If you look at the point A, so that is 2 to the minus 1, which is a half, and the point B is at 3 times a half, which is 1.5. So if I look from the x-axis to B, that distance is 3 times the distance from the x-axis to A. So it's also 3 times the previous value. And if you look on the right hand side, you will have a value there 2, and there you have a 6, so this is also 3 times 2. This is 3 times 1, etc. So now you take this broken line and you shift it down 2 units. So from B at 1.5, you shift down 2 units to get to point C at -0.5. So that's 2 units that you're shifting it down. From 3 up to there is 2 units, so it cuts exactly at the same point that we had before. And from D to E is also 2 units. And if you look here at the x-intercept, you see it's a negative value, minus 0.58. This value is minus 0.58 is approximately 0.6, and you cannot read it off from the graph, but you can calculate it using your calculator and logs. Let us look at the brown graph. We see that we have 3 to the power of x minus 1. So this is typically where we take a function with hyperbola. We have an x minus p, and in this case our p is plus 1. So y equals 3 to the x is shifted 1 unit to the right. Or I can also say p of x is 3 times x times 3 to the minus 1. So that is equal to a third times 3 to the x, and that we did in a previous example. So what it means is that we've shrinked it with a factor of 3, so it means it's 1/3 of the size. So if I look at the domain here, I get R. My range is exactly the same, it's from 0 to infinity, because I just shifted the graph. My y-intercept happens when x is equal to 0, so I get that. So that gives me 3 to the minus 1, which is a third. My horizontal asymptote is the x-axis, and if I look at the graph here, it's very easy to see that it was shifted 1 unit to the right, but you can also look at the vertical shrinking. So if you look here, this is 1, but that is a third. There we have 3 compared to 1, etc. For me, it's easier to do the horizontal shifts, but exponential equations, you can always write that shift as something times the a to the x.